Welcome to Study Loop.
This question is asking us to calculate the density of the Earth in grams per centimeter cubed. So from Appendix E, the mass of the Earth is 5.97 times 10 to the 24th kilograms, and the radius of the Earth is 6.38 times 10 to the 6th meters. We're also going to need to know the volume of the sphere, and that formula is 4/3 pi r cubed. So we'll start by calculating the volume of the Earth. So we have V is equal to 4/3 pi r cubed. So then we have 4/3 pi times our radius cubed, so 6.38 times 10 to the 6th cubed. And we'll simplify that a little and say that's equal to 4/3 pi times 6.38 cubed times 10 to the 18th meters cubed. So density is mass over volume. So we have the mass of the Earth, 5.97 times 10 to the 24th kilograms, over 4/3 pi times 6.38 cubed times 10 to the 18th meters cubed. And we'll first start by converting kilograms to grams. And 1 kilogram is equal to 1,000 grams. So in order to cancel out kilograms, we need to multiply by a fraction that has kilograms in the denominator, so then the units will cancel. So we'll write 1 kilogram in the denominator, and that's equal to 1,000 grams, so we'll write that in the numerator. And now we can convert meters into centimeters. So 1 meter is equal to 100 centimeters, and to cancel out meters, we need to have meters in the numerator, so we'll write 1 meter in the numerator, and that's equal to 100 centimeters, and we'll write that in the denominator. But since we have meters cubed, we actually need to cube this whole thing. So we'll multiply by 1 meter over 100 centimeters, and the whole fraction cubed. And then plugging this into our calculator, we get that the density of the Earth is 5.49 grams per centimeter cubed. For part B, we're asked to find the density of the Sun, and we're given that the diameter is equal to 15,000 kilometers. And according to Appendix E, mass of the Sun is equal to 1.99 times 10 to the power of 30 kilograms. We'll start again by finding the volume of the Sun using the equation for the volume of the sphere. V is equal to 4/3 pi r cubed, and that's equal to 4/3 times pi times the radius. So half the diameter, which is 7,500 cubed, and that's kilometers cubed. So then to find the density, that's mass over volume, so we have 1.99 times 10 to the power of 30 kilograms over 4/3 pi times 7,500 cubed. And since the problem doesn't specify what units we need to convert to, I'll leave it as kilograms over kilometers cubed. And this is equal to approximately 1.13 times 10 to the 18th kilograms per kilometers cubed. Part C is asking us to find the density of a neutron star in grams per centimeter cubed. And we're given that the diameter of the star is 20 kilometers, and the mass of the star is approximately 1.99 times 10 to the power of 30 kilograms. Again, we'll assume that the star is a perfect sphere, and we can find the volume through the formula 4/3 pi r cubed. So we have 4/3 pi times the radius, so half the diameter, which is 10 cubed. And we can simplify this a little since 10 cubed is equal to 1,000. So this is 4,000 over 3 times pi kilometers cubed. So again, finding density is mass over volume, and we have 1.99 times 10 to the power 30 kilograms over 4,000 over 3 times pi times kilometers cubed. And we'll start by converting kilograms into grams, like from part A. So 1 kilogram is equal to 1,000 grams. So we'll multiply by 1,000 grams over 1 kilogram, canceling out kilograms. And now to convert kilometers into centimeters, we'll start by converting kilometers into meters. So 1 kilometer is equal to 1,000 meters. So we'll multiply by 1 kilometer over 1,000 meters. And since we're trying to cancel out kilometers cubed, we need to cube this whole fraction. So now kilometers cubed cancels out, and we're left with meters cubed in the denominator, but we need to convert that into centimeters. So 1 meter is equal to 100 centimeters. So we'll multiply by a fraction that has meters in the numerator, so then the unit will cancel. So we'll multiply by 1 meter over 100 centimeters, and again, since we have meters cubed, we need to cube this fraction. And now all of our units cancel, leaving us with just grams per centimeters cubed. And this is approximately equal to 4.75 times 10 to the 14th grams per centimeter cubed.